Hello, good evening everyone. It's Josh Keegan here and welcome to this episode of the Space Down Under Live. I'm coming to you live once again on the Space Down Under Live. That seems a little bit redundant, but anyway, welcome. Thanks very much for joining us. You would have experienced our previous time we did this, myself and Mark Stephen. We did this last time and it didn't work. It worked well, but the first time before that was an audience of nobody. So that was a lot of fun. So after all, and despite of all that, what happened with all of that, this live stream, I'm joined by Mark again. He's decided to co-host this live stream with me, and he hasn't actually been frightened off by those first two experiences that we initially had. So welcome, Mark. Thanks very much for joining me again. It's good to have you here, buddy.
Hey, Josh. Great to be here, mate. It's this has worked first time this time, so we're going well.
That's awesome. That's a fantastic thing to know. So look, it's that time. Of course, it's the Space Down Under. It's time to grab your favorite beverage, grab a cup of coffee, or at least your favorite beverage, and let's make a start on all of this. So we're actually joined by a very special guest this evening. His name is Giuseppe Calabrese. He's the first winner of the I'm going to get this wrong, I'll have to read it, I'm sorry. The first winner of the Urban Farming Marschitecture 2020 Award for Sprout. He's an Italian from Italy, living in Australia, wrong way around. Giuseppe is a registered architect and violinist. He is particularly active in earth construction. On the earth construction front and contributing chapters to several publications following his thesis on the subject of earth buildings and work abroad, particularly in Saudi Arabia. So, good evening, Giuseppe, and welcome to the Space Down Under Live.
Good evening. Thanks for having me, Josh.
Good evening, Giuseppe. Great to see you.
Thanks, Mark.
Yeah, good seeing
you.
Yeah, look, congratulations on the award that you received at the December last year. That was a bit of a shock and a bit of a surprise to us here in Australia to actually find that you had done that. Congratulations, well done. And can you explain mate, about what the Marschitecture award is all about?
Okay, so basically the goal was to, the question was how to support a human life on Mars for a period of 2 years for non-astronauts through sustainable produce farming. So we had to, that was pretty much the brief. Then how each of us was going to get through to that was different. Basically, I came up with a structure that was going to house some cylinders, basically cylinders that would be sent by planet Earth with seeds, so pre-implanted. And then this would be basically, they would be sprouting. So when the astronauts would arrive, they basically already had a produce. So now this would all have been built previously with real-time telerobotic systems and co-robots and robotic systems that basically they are AI intelligence, all operated from planet Earth. So the whole system would be set up. And from planet Earth, when the astronauts arrive, they already find a construction with the cylinders inserted and produce ready to be harvested.
Okay, so what we'll do is we'll actually have a look at the winning design. So here is the Sprout habitat.
In the proximity of the ancient delta, AI robots will install battery storage containers, nuclear energy generators, and solar farms. Following this, they will create bricks from extracted smectite of the delta and use extracted basalt fibers and bioplastic for 3D printing. AI will be digging trenches and printing foundations for the algae pools of the Green Powerhouse, a system invented by Michael Smith. After installing the photosynthetic collector core, compressed bricks will be locked together to form the walls, and the whole structure will be closed with 3D printing of the Nubian vaults. Extracted silica will be shaped into glazing to close each end of the vaults. The Green Powerhouse mimics natural biological processes. It is an integration of 3 subcomponents: photobioreactors, anaerobic bioreactors, and organic carbon engines that work together to convert biowaste into energy and soil amendments. The photobioreactors utilize a light source to cultivate algae. The anaerobic bioreactors will convert algal biomass into methane, hydrogen, and organic fertilizer. The organic carbon engine is a biomass-powered device that generates biochar, a product that locks in carbon and generates soil at 1000 degrees Fahrenheit in absence of oxygen. Byproducts will include electrical power, high-grade organic fertilizers, and soil amendments. Once the green powerhouse is built, the laydown of the bricks will proceed to create arms of a secondary structure, hosting and protecting greenhouse cylinders and habitat modules. The arms will be capped with 3D printed Nubian vaults, with glazing, permitting natural light penetration. The plant's main source of light will be from LEDs alimented from solar collectors. The greenhouse cylinders will provide bio-waste to the green powerhouse, and the green powerhouse will supply biochar in return. Sprout is a system that produces no waste in a perfect closed circle. Once the shielding walls and roof structures are completed, the pressurized greenhouse cylinders will be opened and placed. Seeds will sprout and crops will grow and flourish while earthlings approach. At their arrival, waste from crops will be moved into the green powerhouse and dealt with immediately, creating the power that will sustain life on planet Mars. With the expansion, a seed vault and insect processing area will be added. Sprout introduces a self-sustaining, self-managing ecosystem that can be utilized for the year-round production of organic food in virtually any climate, with both Earth and Mars applications.
So that design that you've come up with there, so how did you end up coming up with all of that? Was it just an inspirational moment, or did you actually take elements from various areas? I mean, there was some there that you said that were previous previous ideas from other reactors and all that sort of stuff. So how did you come up with the final idea?
So basically, Josh, the idea came about after 3 months of reading scientific papers. So it wasn't just about doing a fancy structure or something like that. So I took this strategy of science. So basically, reading through professors' papers and published information regarding plants, botanists, vertical farming. And then there was a lot of study on planet Mars. Yeah, no atmosphere, no magnetic field, extreme temperature changes, all sorts of situations. So whatever you could think about is completely opposite than planet Earth. So before even thinking about a structure, I had to go through all the parameters, if that makes sense, and just that whatever I was designing had a minimum possibility of having a success. So. Yes, a lot of scientific papers, that was the start. Then because I have a background in earth construction, I started, via the scientific papers, I started doing a lot of research where there was a particular type of clay that could be useful for the bricks that I wanted to use. So what were the ISRU, the in situ resource utilization, the materials that were there that I could use? Because of course we're not going to transport sand and bricks over there. And yes, then I basically united that information of the earth bricks and the earth construction on our planet with all the scientific information. And then I came across a physician called Michael Smith, and he's basically got 35 years experience also in AI. And I went through all his system. And then basically I found a lot of relationships with all this information that I could use, and basically it molded the shape into what we see now.
Oh wow! So there was so you also took into account like I've heard that the data sent back from Mars with the Martian regolith is actually it's very dead. There is no organic matter in it, that we've discovered yet. So obviously you've taken that into account as well as the overall structure of the regolith as well. I think it's very interesting and unique that you've Actually, you've got the compressed regolith that would actually looks remarkably similar. I won't mention the name just for potential violation of copyright, but yeah, it looks awfully familiar to something else that many kids would have at home. A very common substance. Was there a reason for that? Were you tripping over someone's Lego late at night yourself, and you thought, oh, that's a perfect idea? No, yeah. So how did that come about?
No, you basically nailed it. Josh, yes, that exactly the inspiration from the kids' toy. Having studied a lot of Earth, basically, we have on our planet compressed bricks, and the compressed bricks. Well, obviously, we're over on a planet where we only have limited resources. So rather than having, I thought about a system that could be mortarless, basically. It could just be a joint together and clicked together, built by machines. You see, initially I had thought about covering those internal cylinders, the ISS cylinders that contain the planets, with sort of a Nubian vault rather than straight walls, or having some different vault structure. But when you have different types of vaults, all the bricks are completely different, if that makes sense, because they are not, you can't just glue all the bricks together. They need to be shaped in a certain way over a vault. So the best way was to build the walls straight by artificial intelligence, and then 3D print the basalt vault on the top. So yeah, it was just the logic that I followed, basically, that could be done by machine. There's a lot of ways of doing it, and this is not a final solution, of course. It's just, I find it's just a step in getting there. And obviously there's a lot of things that need to be perfected, but it's got a good chance. Yeah.
Okay, excellent. So I've just noticed as well that the lot of the just in behind yourself, that you've got a picture of what seems to be one of the Martian rovers, which is currently on Mars at the moment. It looks like the Perseverance rover and stuff like that. Did you actually take inspiration for the robotic systems from that because it was already in play, or was it a yeah? How did you come about that design?
Of the rover itself.
Yeah, the rovers for the construction portion of it. Yep.
Yes. Actually, I didn't do much research in the Perseverance at all. I did a lot of research on the Jezero crater. A lot of satellite imagery came up with a different location of the smectite, which is a particular type of clay that I used to form those bricks. In terms of the machinery, I basically just thought that the rover that was there would have different attachments. So one attachment was going to compress the smectite, and then it was going to basically fire it and microwave it. And then another attachment, as you can see just at the back of me, the scissor hoist, it would be another attachment which would lift the blocks. And then there was a third attachment that had basically a mechanical arm for the 3D printing. So I was thinking maybe 2 or 3 rovers with different attachments could have done all the job and bring it to completion. So not an army of little machines, but rather just 2, 3 of them.
Okay. Yeah. All right. Good. Mark, did you have a question?
Yeah, I was just wondering. You briefly touched on it earlier, but when you first go about designing this, this city, where does your mind immediately go to? How do I design it, or what do I have to design it with? If you know what I mean, like, where does your mind first go that you need to figure out before you can take the next step in actually the design process?
Yes, that's a good question, Mark. The process of design, I never find that it's linear. Like, it doesn't go from A to B or from A to Z in a straight line. It just goes in all the way of the alphabet and goes backwards and goes straight. I actually, my line of thought was more thinking about ISRU. So what could I use? So scientific perspectives. I didn't want to do just a fancy curved Zardid building or like an opera house in the middle of Mars just for the sake of doing something pretty. I think that is what's called a stage 3 building. Like once we're established, we go on. So this would be more like a stage 2 building, which we're utilizing materials that are there, and it's something a little bit bigger. And it's also, it has in account also structures built from Earth. So it's a bit of a hybrid. The structures, I didn't want to propose something too further in the future. It was something that could actually be used, and it was more down to earth, if we want to call it.
No.
Materials that are there, those are the materials. And I'm sure that Perseverance now will be sending back samples, and there'll be a lot more like scientific.
Well, that was actually going to be a follow-up question. I mean, how closely are you monitoring the Perseverance mission, over the next few years to see, what you've designed, can be used with what the scientific data Perseverance gets,
I mean, I'm following everything as close as possible. I wish I was really working for those big companies, because it's so exciting. I mean, everything is Mars. There's a lot of talk about space tourism, and everything is just taking off also with 3D printing. I'm going to follow as close as possible. Then when the rover will be sending back the samples, that will be so fascinating. I don't know what the chances are that my project will have a feasibility of being built, but I think, as I said, it's just a stepping stone, that together with a lot of other stepping stones by other designers and other scientists, we all will be achieving getting to Mars. I don't think it's a thing that can be achieved by one person. It's a collective.
Yeah, absolutely. And just one more question for me before I throw it back to Josh. Obviously, you mentioned as well, how different Mars is to Earth. It's completely opposite. Can you point out one thing that troubled you the most? I know there would have been a lot of things, but was there one thing that, really took a while to sort of get over that hurdle?
I'll probably say the thermal excursion. So the change of temperature is huge. So basically I had to find a way to protect the vegetation in these cylinders, and that's why those walls are very thick, and they're protecting from, there's all sorts of radiation coming against the structure. So you can't just simply build a greenhouse in the middle of nowhere. Everything it will have no chance of survival. I'll say the temperature.
Okay, interesting. No, it's cool.
All right, cool. Just in regard to all of this, Giuseppe, in regard to, you were announced the winner and all that sort of stuff. It seems like you were at home. So what we'll do is we'll actually just watch that video of the announcement of you winning the award. So we'll just take that right now.
And the first winner of the Mars City Design Urban Farming Challenge 2020 in the category of Marschitecture is Sprout by Giuseppe Calabrese.
Oh my God, did I really win?
There it is. Congratulations, Giuseppe.
Very grateful. Just thanks so much. I wish I could be there. I don't think this year we can travel anywhere.
Congratulations, Giuseppe, and congratulations, Justin, on a great job. And really to all the contestants for putting in a lot of amazing work. You guys did some impressive work, and hopefully we can use that on the planet of Mars, which is literally, I'm looking at it right now. It's directly above me here in Dubai. So congratulations, guys. Bye-bye.
So, Giuseppe, what was that moment like to actually, actually get that, be rewarded or chosen as the person who actually was recipient of the award. What was that moment like? I mean, it looked very emotional from the camera that was watching you, I assume at home. But what was that moment like, and what's life been like since?
Yeah, I basically had a bit of a breakdown because previous to that, I was communicated that I was in the first 10, and I honestly could not believe that. I mean, I participated in some other competitions, and there's thousands of people participating. I was at a music school where I teach, and I was just doing some work, and I was, all sweaty. I had this laptop. It happened to have it around, and they told me, can you come online in an hour? I said, oh, what's this about? I said, no, we need to communicate something regarding the top 10. And then all of a sudden there was this, I didn't actually get that video. It was just an audio. They made this audio go on, and I couldn't really understand. They were talking about announcing some winners. So I kept on listening, and then I just realized, Vera Muliani, the CEO of Mars City Design, was saying that, I won, and I had a breakdown, because then after we had a chat, and she said that there's thousands of entries, and there was international offices this time, because due to COVID, a lot of offices had free time. So there was collaborations between big offices, astronauts, scientists, so that people had teamed up, big firms, and I was just puzzled as how, really, I could not believe that I even had a chance at the time of making the top 100, not to mention actually winning. So I started crying, because I started shaking, and it was really, really strange sensation. Yeah.
And how's life been since winning the award? This always fascinates me. Is that I don't really win awards, so that's good. It probably is better and easier on my life. But for yourself, how has life been since winning the award? Has it picked up and you've been really, really busy, or has it remained relatively the same? Or do you do like I do? This is why I don't win awards. Is oh, wow, I'm the best. Does that sort of stuff hit you or happen to you at all?
I say this. I actually I'm very realist. So I've had a lot of interviews and a lot of emails. A lot of people contacting me. I think I'm now part of a consortium. Basically, we do a lot of research on the moon and publish papers, scientific research. I would like to get into PhD in space architecture, but I'm doing a lot of study at the moment on what area to get in. But no, it hasn't really hit me, or I haven't become mad at all. I just have been kept on going with my life, really. I have to keep on studying, and I mean, it's fantastic what's happened, but one has to keep on going and doing research and keep on moving in the right direction, I suppose, of their dream. No, NASA hasn't contacted me, and neither has Elon Musk at the moment.
Oh, that's a shame.
Yeah, that's a real shame.
The Moon project.
Sorry,
we talked both at once. My apologies. Go Mark.
Oh no, you go, Josh, and then I'll ask.
Yeah, I was just going to say, have you put in for the Dear Moon project there, Giuseppe, or is that so? With it's going around with never get his name right, the Japanese billionaire who's actually going to be traveling on the first starship around the moon in 2023 or 2024, depends on delays and all that sort of stuff. Have you put in for something like that?
No, I haven't booked my ticket yet. I know they're searching for astronauts, but. To be honest, I'm not that type of. I think it would be fascinating, but in a later stage, I could not live in a claustrophobic situation with a helmet over my head. I think everybody's got their time and their space. I'll leave that to the professionals. I'll probably go when things get a little bit more comfortable. It's just another level that sort of training that you need to get into. Yeah.
Mark?
Yeah. So obviously, we saw with your reaction, how how much the award meant to you. How do you feel thinking that one day on Mars there could be, a building there, with your concepts, with your name attached? What emotions does that bring up? To think in the future that Giuseppe Calabrese will be associated with, humans living on Mars.
Well, that would be, that would be a big, very, very big thing. I believe that in the brief of the competition, what they were going to do was to build a prototype in the Californian desert. At least maybe it's just going to be a branch of this because, these sort of things will be very expensive. And then possibly there could be maybe they could utilize part of this as an experiment on Mars and couple it with other experiments. Maybe there'll be some sort of hybrid, but I don't know. I can't even start to think if, this would be realistically built on another planet. Probably give me a complete breakdown if I ever saw this on planet Mars.
Yeah, no, but no, it'd be. I reckon, this is the thing, though, and in where we're at in planning for humans at Mars is all these ideas matter. It could be a little idea from this, a little idea from another thing and another thing that allow, as you said before, it's going to take a collective effort for humans to be able to live on Mars, So, in some way, shape or form, a concept from this will be needed, most probably.
Yes, I did get some good comments from various scientists. They were saying that finally there's some design that's got a merit of and a possibility of being built. I have seen a lot of structures that they're all fantastic and we're all aiming at the same moving forward. But some structures, they are just too futuristic, or just too pushed towards thousands of years in the future. Where and I think what we need to think about is more, what do we have, what can we utilize, how can we move forward one step at a time. So thinking more close term and more realistic, more scientific, rather than too dreamlike, with all these curvy structures and certain gases or certain, the reality is that's what we have and that's what we can use. So that's my approach, really.
Yeah, no, it's great.
Absolutely, and that's the thing, is you make a good point there, Mark, is that this actually others may stand on your shoulders, Giuseppe, and actually utilize your design to actually enhance their designs the same way that you've used concepts from other people who, and you're standing on the shoulders of giants yourself to actually come up with your initial design. So I think that's well and truly to be commended. And the fact that you're living here in Australia is, honestly, I'm going to claim it. I'm sorry, Italy. I apologise up front, but yeah, I'm going to claim it. This one's for us, for Australia. So I apologise to the entire continent of Italy. Sorry, the entire country of Italy. So that's my fault. But yeah, but the fact that you're living here is a good one for us, for Australia, and it's a fantastic thing. I just think that it's also interesting as well that I watched one of your videos as well that you. Just quickly, if we can touch on it just briefly, you actually play the violin. So if you just give me 2 seconds, I'll just play a brief clip of you playing the violin. That is just amazing. That's beautiful. It's amazing that you design things on Mars, and also for leisure you play the violin. And there is a whole video on Vimeo, I believe, in regard to you playing the violin and how it actually relates to architecture. So if you could give us just a real quick brief overview of how architecture and playing music or playing the violin relates.
Yes, Josh. There's Vitruvius, for example, when he was designing the columns in the temple, he would use certain intervals of music. So when I was at architecture, we were doing all these drawings of the columns and proportions and how they all work. He was using certain geometries and distance between the notes to proportion them. And I think nature has a way of working with this type of intervals as well. Music, and when I teach music, I'm still thinking about design, and when I design, I think about pieces of music. I don't know how the mind works. I keep on bouncing between the two, but they're definitely both creative parts of the brain, and a little pinch of science, I think, is necessary to go ahead. But yes, music has been present in the past and in a lot of architecture. So if we start digging, you'll see a lot of proportions have been coming from music itself. Yeah.
Yeah, it's fantastic that I think that you will when you think about music, you're thinking, or when you're playing music, you're thinking about architecture, and vice versa. That when you're thinking about architecture, you're thinking about music, and that's just a beautiful way to wrap up this entire interview, I guess. And to thank you very much for your time. Thank you very much for your time this evening in talking with myself and for Mark. Congratulations on the award, for winning the award. Very well done. Again, congratulations to Italy, but you're in Australia, so we're claiming it.
Absolutely. You know, congratulations, mate. You've done yourself proud, and I'm sure your family and friends are proud too.
Thanks so much. Thanks for having me, and yeah, it's been a pleasure.
No, it's been great. Thanks so much for joining us.
And we hope you'll join us again one day soon.
Absolutely.
Cool.
All right. Well, thanks very much,
mate.
Everyone, for joining us at the Space Down Under. Thanks very much once again, Mark, for joining us as well. And thank you again to Giuseppe for actually joining us here at the Space Down Under live edition. This went reasonably well. I think there will probably be some critical notes where I review this back. But thanks very much for taking the time, everybody. So everyone, have a very good evening, and we'll see you again next time for the Space Down Under live.
See ya.